here with Martin Schreyer, who is an application specialist at Malvern Panalytical. And Martin, we are going to discuss computed tomography on a diffractometer. What's that? CT scan.
Well, basically, it's the most simple application of them all. You need a two-dimensional detector.
Yeah.
You need a white X-ray source with literally no collimation at all, just white going out like a torch, and you collect a lot of images.
Have you ever been in a CT scan or ever had a CT scan?
Well, much rather that than being dismembered by my brother. He's a medical doctor, you know.
Yeah.
And
it'd be nice to know what you look like on the inside, right?
Yeah, I would be curious, actually.
Yeah, but explain, what's the technology about?
Well, basically, it's the technique that I like to say Konrad Röntgen almost invented. You know, one of the first images is the one of his wife and the ring finger. Mm-hmm. And if he had rotated her hand all a little bit, collected lots of images and had figured out how to reconstruct the 3D images, he would have invented computed tomography at the same time.
But he was way ahead of his time, right?
Well, he would have been very much ahead of his time. So actually, as easy as the technique sounds, as difficult it is to process all these data. So the mathematical concept for the reconstruction was invented by Johann Radon in 1916.
Oh, so there was quite a bit of time between.
Yeah, and when really reconstructing it actually, well, it was so difficult to handle that it was like trying to make a rope out of sand. So computer technology had to catch up quite a bit until that became a practical application, which was in the 1960s. Mm-hmm. And I think one of the first CT scans is one of the human head. So medical applications pretty much immediately came in. And it's been a growing field ever since. And in 2010, we launched our first 2D detector. We called it the Pixel 3D because it enables 3D applications, aka CT. So we thought, well, what can we do special, which no one else can do on their multi-purpose platforms? And I thought, well, we've got a 2D detector now. How about computed tomography? And you would want to know, what does your tablet look like in the inside? Are things homogeneously distributed?
How thick is the coating?
Yeah,
perhaps?
Things like that. Is the coating really homogeneous or so on? Or is it actually your own product or is it some fake product? You can also tell that.
Oh, so you can check if it's fake or if it's yours?
Yeah, because things may not be quite the same in structure. So the coating may be a little bit thicker, the distribution of particles inside may be a little bit thicker, a bit different. So it's actually quite complex to really do a good fake product.
It's complex to do a good fake product. That's a good one. We'll keep that in mind. How long does it take then to actually check if it's fake or not?
Depends on the settings, but typically around 15 to 20 minutes. And you've got all the pictures, and then the hard part is doing the reconstruction. So you need a rather nice, powerful computer with a good graphics card. So what they use in gaming, really.
Okay.
And do the reconstruction there.
Okay. Well, thank you for this introduction in CT technology.
Yeah, thank you.